Welcome. This video is about remote access with SSH. We will explore how to securely connect to and manage remote systems using SSH. Let's begin by understanding what SSH is. SSH, which stands for Secure Shell, is a cryptographic network protocol. It provides secure remote login and command execution. Importantly, it encrypts all traffic between the client and the server, ensuring privacy and security. SSH is the standard for remote administration of Unix and Linux systems. In a typical scenario, a client computer connects to a server computer using SSH. This connection is secured using encryption, represented by a lock symbol, to protect the data transmitted between the client and the server. Now let's compare SSH with Telnet, another remote access protocol. On one hand, SSH offers encrypted communication, strong authentication methods, protection against eavesdropping, data integrity verification, and file transfer capabilities through SCP and SFTP. On the other hand, Telnet uses plain text communication, offers only basic password authentication, is vulnerable to packet sniffing, lacks data integrity checks, and is limited to terminal sessions. Therefore, SSH is much more secure and feature-rich than Telnet. Let's explore the key components of SSH. The SSH client is the software on the user's computer that initiates connections to remote servers and provides the user interface for remote access. The SSH server is the software running on the remote system that authenticates clients and provides secure access to the system's resources. Authentication methods are the mechanisms used to verify identity, including password authentication, public key authentication, and multi-factor authentication. Finally, encryption protocols are the cryptographic algorithms that secure the connection, including symmetric encryption, asymmetric encryption, and hashing. Let's discuss some basic SSH commands. To connect to a remote server, you can use the command SSH username at hostname. This command establishes a secure connection to a remote server using the specified username and hostname or IP address. To connect on a different port, you can use the command SSH port number username at hostname. This command connects to a server using a non-standard port. The default port is 22. To connect with a key file, you can use the command SSH/ID_RSA username at hostname. This uses a specific private key file for authentication instead of the default key or password. Finally, to run a command remotely, you can use the command SSH username at hostname, ls/la. This executes a command on the remote server and returns the output without entering an interactive shell. Now let's look at SSH Key Authentication. The first step is to generate a key pair. Create public and private keys using the SSH keygen command on your local machine. The second step is to copy the public key to the server. Add your public key to the server's authorized _keys file using SSH copy ID or manually. The third step is to connect without a password. The SSH client uses your private key to authenticate, eliminating the need for password entry. The fourth step is to secure your private key. Protect your private key with a passphrase and proper file permissions using chmod 600. In summary, the client generates a key pair, the public key is copied to the server, and the private key is used for authentication. Now let's discuss the SSH configuration file. Using an SSH config file simplifies connections to frequently used servers with custom aliases. It specifies which identity file to use for different hosts. It also defines custom ports, usernames, and other connection parameters. Additionally, it configures proxy jumps and connection forwarding. It also sets connection timeouts and keep alive intervals. Here's an example of an SSH config file located at /ssh/config on Linux or Mac OS, and at c:/users/username/ssh config on Windows. The file allows you to define default settings for all hosts, as well as specific configurations for web servers and database servers. Let's delve into SSH Port Forwarding. There are different types of port forwarding: local port forwarding, remote port forwarding, and dynamic port forwarding. Local port forwarding forwards a port from your local machine to a port on a remote server, allowing you to access remote services as if they were local. The command for local port forwarding is SSH-L8080, localhost, 80 username at remote_host. Remote port forwarding forwards a port from the remote server to your local machine, allowing remote users to access local services through the SSH server. The command for remote port forwarding is SSH-R8080, localhost, 3000 username at remote_host. Dynamic port forwarding creates a SOCKS proxy on your local machine that routes traffic through the SSH server, allowing for dynamic access to multiple services. The command for dynamic port forwarding is SSH-9090 username at remote_host. Common use cases for SSH port forwarding include accessing web services on internal networks, securing database connections, bypassing network restrictions, creating secure tunnels for remote work, accessing services behind firewalls, and exposing local development servers. Now let's look at file transfer with SSH using SCP and SFTP. SCP, which stands for Secure Copy, uses SSH to securely transfer files between local and remote systems with simple command line syntax. SFTP, which stands for SSH File Transfer Protocol, provides a more interactive file transfer experience with additional file management capabilities. To copy a local file to a remote server using SCP, use the command scp localfile txt username at hostname /remote/path/. To copy a remote file to a local system, use the command scp username at hostname /remote/file.txt local/path/. To copy an entire directory recursively, use the command scp our local/directory/username at hostname /remote/path/. With SFTP, you can connect to an SFTP session using the command SFTP username at hostname. Common SFTP commands within a session include get remote file local file. To download a file, put local file remote file. To upload a file, ls to list remote files, cd directory, to change the remote directory, and dir directory, to create a remote directory. SCP offers simple, familiar copy-like syntax, is good for quick, one-time file transfers, and uses existing SSH authentication. SFTP, on the other hand, provides an interactive shell for multiple operations, allows resuming interrupted transfers, supports directory listings and file management, and is better for complex file operations. Finally, let's cover some SSH security best practices. First, use key authentication by disabling password authentication and using SSH keys with strong passphrases for better security and convenience. You can edit /etc/ssh/ssh and set password authentication no. Second, change the default port to a non-standard port to reduce automated scanning attacks targeting the default SSH port 22. You can edit /etc/ssh/ssh_config and set port 2222 or another unused port. Third, limit user access by restricting SSH access to specific users or groups who need remote access, and disable root login. Set permit root login no, and allow users user 1 user 2. Fourth, implement timeouts by setting idle timeout intervals to automatically disconnect inactive sessions and reduce the attack window. Set client alive interval 300 and client alive count max 2. Fifth, use fail2ban to detect and block IP addresses that show malicious signs like multiple failed login attempts. Install with sudo apt install fail2ban and configure for SSH protection. Sixth, keep software updated by regularly updating your SSH server and client software to patch security vulnerabilities as they're discovered. Run sudo apt update and in sudo apt upgrade OpenServer. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.